Okay, here is going to be the example problem. Okay, you have steam. It's at 100 psi and 400 degrees Fahrenheit. It enters an insulated nozzle. Okay, with a velocity that's equal to 200 feet per second. It leaves at 20.8. Let's just do this. Let's just do 20. It leaves at 20 psi. That'll be easier for you. 20 psi, and a velocity of equal to 2,000 feet per second. So what I want to know, my question is, what is the temperature if superheated? What is the quality if saturated at the exit? Okay, so we're looking at this situation and we're going to say, well, steam's coming into a nozzle, leaving a nozzle. And I want to know if that steam leaving the nozzle is superheated. I want to know what the temperature is. If the steam leaving the nozzle is actually gone into the vapor dome and now has a quality, give me that quality. Okay, that's what I want to know. So first thing I'm going to do is I'm going to draw a picture of my nozzle. Okay, here's my nozzle, and I have state 1 and I have state 2, and I'm going to go ahead and I'm going to insulate this puppy. There we go. And I have flow go in this direction. We're waiting. We're thinking about this. Okay, and then I'm going to go over here and write the states. Hang with me here. Okay, state 1. The pressure 1 is equal to 100 psi. The temperature 1 is equal to 400 degrees Fahrenheit. And the velocity 1 Okay, my laptop is not one to do this, and I don't know why. I have to figure this out. So I'm gonna change over here. Hopefully my document camera is on. Let's see if the document camera works. Oh, we're good. We're good. We're good. We're good. We're good. So here's what happens: 100 psi, 400 degrees Fahrenheit. Velocity is 200 feet per second. If I were to check this, superheated. I know. Pressure 2. 20 psi is all we know. We do not know the temperature. We know the new velocity is going to be 200 feet per second. Okay, so I do my continuity equation. Mass of the control volume over time is equal to m dot in minus m dot out. I know it's at steady state. Now, they didn't say it in the problem statement. It didn't say steady state. I'm going to assume it's steady state. Okay, mass in is mass out, same as mass. For my energy equation, what I'm going to write down here is I'm going to write down the entire energy equation, and I'm going to go through here and use my common assumptions. There's no change in energy in my control volume with respect to time because it's steady state. Insulated. No shafts. No potential energy change. And so that gives me down to this equation. m dot h in minus h out plus v in squared minus vx squared over 2. Okay, here. Now, I know that in this, either the m dot has to equal 0 or what's in the parentheses is equal to 0, and I don't want m dot to equal 0. So that gives me this equation, the enthalpy exiting, because that's what's gonna set my state, because I need to have two things set the state. I have a pressure. I need the second thing to set the state. So if I find the value for the enthalpy at state 2, I can go figure out what my state is. Okay, so I go down here and I say, well, at state 1, at 100 psi and 400 degrees Fahrenheit, I find a value of 1,200 and 1,227.5 BTUs per pound. Then I add in my change of kinetic energy, 200 squared minus 2,000 squared over 2 feet squared per second squared. Remember what I just said? There's an issue that we have to deal with the conversion of feet squared per second squared to BTU per pound. We can't add BTU per pound to feet squared per second squared. So here's the conversion. Okay. Now, what I want you to do is I want you to complete this problem. I want you now to go and just, it's right there for you. I want you to plug it into your calculator and I want you to find out what the value for H is. And then you're going to have to go look at 20 psi and you're going to find out, is that H value above the saturated vapor? If it is, then you have a superheated and you must find the final temperature. If it isn't, it's saturated and you need to find the quality. And you need to provide the answer to me. Either you find the temperature or find the quality and put it into the blank here for the lecture quiz, and that will be what we leave you with today. So that's the lecture for today. We'll do more and more problems like this in class and in lecture over the next 4 or 5 class periods. So this is again what we'll keep talking about until going up to the next exam. Until then, we will see you later.